Hey Condors, it's your boy Mr. Roberts here with another episode of Social Distancing Science. Hey, before we get started, don't forget to hit that subscribe button and mash that bell so you don't miss any future episodes of Social Distancing Science. Let's check out our agenda for today. We've got a few things we're going to do. We're going to encounter the phenomena exploring the universe. We've got a module pretest about exploring the universe. Then we've got a science probe about gravity in space. We're going to encounter the phenomena of gravity and the planets. We're going to do an investigation about falling apples. We're going to read about what is gravity, and then we're going to do a little 3D thinking about gravity. Okay. So, how did the universe and other celestial objects form? Let's look at a video to see a little tour of the universe. Hey, I live there. Okay, we don't need to watch this whole video. Let's continue on. So, can you develop a list of questions that you think of when you look at this photo? Write your questions here, and then let's continue on. To the pretest. Don't forget, it's a pretest. This does not affect your grade. Just want to see what you guys know before we start. So, first question. What is the basic shape of every planet's orbit? Is it a circle, an ellipse, a square, or a triangle? Can you explain why scientists no longer consider Pluto to be a planet? Is it because scientists discovered it does not orbit the sun? Scientists found that Pluto did not have any gravity. Scientists changed the definition of a planet based on new information, or scientists decided there should only be 8 planets in the solar system. Which statement explains why the objects of the solar system revolve around the sun? Is it that the sun holds 99% of the mass in the solar system, so it has an enormous gravitational pull? Is it that the sun generates its own energy, so the planets stay close to absorb heat and light and stay nice and warm? Is it that light waves from the sun cause the planets to revolve around it? Or is it that heat energy from the sun attracts the planets and keeps them in orbit? Now, a student draws a scientifically accurate model of the solar system. Which is not a piece of information that the student needs to make their model? Is it the size of Mars, the shape of the Milky Way galaxy, the distance between the sun and each planet, or the shape of Earth's orbit? Okay, just one more question. Zach uses data collected from Earth-based telescopes and space-based instruments to study characteristics that Mars and Earth have in common. What characteristics of Mars required a space-based instrument to observe and is similar to a characteristic of Earth? Is it the diameter of the planet is 4,220 miles? Is it that the thin atmosphere contains mostly carbon dioxide? Is it that the complex surface features provide evidence of water erosion? Or that the reddish appearance is due to iron compounds in the rocks that cover the planet's surface? Okay, let's get started with our probe now. Olivia asked her friends what they knew about gravity in space. This is what they said. Who do you agree with the most? Justin says there's no gravity in space. Taylor says that gravity only exists on planets. And Juanita says gravity is a force that exists between all objects that have mass, even in space. Select one and then explain why you agree in a sentence or two. Okay, let's encounter the phenomena of gravity and the universe. So, how do celestial objects like galaxies form? Let's watch a little video. At the end of the video, you'll need to write a description of what you saw happening.
Our sun is just one star out of billions of stars in the Milky Way galaxy. How did the Milky Way and our solar system form? The material that makes up the Milky Way galaxy likely resulted from the collisions of smaller galaxies. The spinning collection of gas and dust formed a spiral disk of matter. Our solar system began as a dense region of dust and gas within this disk and formed in stages. The gravitational attraction of a concentration of matter in a cloud caused the cloud to begin collapsing. As the cloud collapsed, it spun faster and flattened out into a disk, called a solar nebula. As the cloud contracted, the temperature increased. Eventually, the pressure from the material in the center of the disk became high enough to allow nuclear fusion to begin, and our sun was formed. The rocky material outside of the center of the disk continued to condense and form larger objects. In the outer regions of the disk, ices condensed from gas. Tiny particles collided and accreted rapidly. Through repeated collisions, they eventually formed the planets. A similar process is thought to have formed moons of the large gaseous planets, such as Jupiter.
Okay, let's move on. Can you discuss write down what you observed? Come up with an idea of how you think these objects may have been formed. Okay, we've got a quick little investigation about falling apples. Have you ever dropped your books while walking to the classroom, or bounced a basketball in gym class? The force that is responsible for the books falling to the floor and the basketball falling to the ground is the same force that holds the planets in orbit. How is this possible? Let's investigate. Examine the figure to the right. Explain why the apple falls to the ground. Now, what if it was a bunch of bananas falling instead of a single apple? Hypothesize why the banana would exert a greater force than the apple. Now we need to do a little reading. What is gravity? The law of universal gravitation. Gravity is the force that every object exerts on all other objects because of their masses. The force of gravity between two objects depends on the object's masses and the distance between them. The more mass either object has, or the closer together they are, the stronger the gravitational force. For example, the gravitational force between the moon and Earth is greater than the gravitational force between the sun and the Earth due to the moon's proximity to Earth. Mass and distance affect the strength of gravitational forces between the objects. In models of gravitational force, this strength is represented by the thickness of arrows. The thicker the arrow, the greater the force between the two objects. Observe the examples shown below. Before we do that, hey, do you notice these arrows are always equal and opposite? I wonder where we heard that before. Now, the two objects in row A are the same distance apart as the two objects in row B, but one of the objects in row B has more mass, creating a stronger gravitational force between the two objects in row B. All four objects in rows C and D have the same mass. The two objects in row C are closer to each other than the two objects in row D, and therefore have a stronger gravitational force to them. Okay, let's do a little 3D thinking about gravity. So the circles below are models representing the bananas and apple from the discussion on the previous page. Object A represents the bananas and object B represents the apple. Draw arrows of different thicknesses to indicate the strength of the gravitational force exerted by the objects in relation to the ground. And last but not least, hypothesize how this information on gravitational force could be applied to planets and stars. Okay, that's all we're doing today. Hope you are having a great day, and I will see you all on Wednesday.